Welcome back, guys. This is me again, soldiering through, doing the exponential function, and then we're going to stop here. All right, and then my husband will do with you guys the inverse functions. Okay, please don't forget to like our videos as well as subscribe to our channel. Now, the exponential function. All right, so in grade 10, or whenever you learned this, but I did it grade 10 many years ago. You had your basic function here, okay, where it's basically a times b to the power x. So how does that actually look like? Okay, so it depends whether a is positive or negative, and we're going to start with when a is positive, and then we're going to then go over to when a is negative. Okay, so when a is basically positive, you're going to have a function that does this. Okay, and it always passes 1, guys. Okay, it passes 1 provided that there hasn't been a vertical shift yet. Okay, so in this case with the exponential functions, you also have asymptotes. In this case, your asymptote would be y is equal to 0. So provided that there is no vertical shift yet, vertical shift presented by q, then it will pass or it will intersect the y-axis at 1. Okay, so your y-intercept will always be equal to 1. All right, and in this case, there is no x-intercept because that is where our asymptote is. So this function tries to touch the x-axis, but it never does because we have an asymptote there. So that is when a is positive. Now, what happens when b is actually a number, what do you call it? If it's actually 1 or higher, okay, if it's 1 or higher, then it will represent, a shape like this as well. So in this case, you have a that's bigger than 1, and you also have b that's bigger than 1. But if you were to have b that is actually in between 0 and 1, it's like a fraction sort of, okay, then you would get a function that is like this. And maybe typical examples would be if you had y is equal to 2 to the power x, okay, that is when a is bigger than 1 and b is bigger than 1. But this side where you have y is equal to 2 to the power negative x, okay, but it's commonly written as y is equal to a half. Remember 2 to the power negative 1? That is actually a half, okay? So that's what I meant by when you have b that is in between 0 and 1, in this case a half, then you would have this function over here, okay? So a is still bigger than 0, but b is in between 0 and 1. Here, a is bigger than 1 and b is bigger than 1. I hope I'm making sense and I hope you're actually understanding. Okay, so that is when you have a as a positive. But now, what if you have a as a negative? Okay, this is your y-axis, your x-axis. Well, basically, remember you had a function like this before, but now it's going to be different. You're going to actually have a function like that, where again it passes the negative 1. Okay, so in this case you would have that a is actually less than 1. It's actually a negative value, okay, and then b in this case, that would be bigger than 1. But in a case where now b is in between 0 and 1, it would basically do that. Okay, but these kinds of, I don't know, this scenario over here, I hardly ever see it in written past papers, but I'm not saying you shouldn't know it. They can test you on anything, so please make sure you know and you understand. Okay, so in this case, again, a is smaller than 0, but b is in between 0 and 1. Okay, so yeah, That is basically it with these, the function, but that is just your normal first one, okay, where there aren't any shifts, okay, and here you still have your asymptote as y is equal to 0. All right, if we look at the second one here, where there are now shifts, which is what you learned in grade 11, basically the shifts that are happening, vertical shift as well as horizontal shift. So here it's basically just the vertical shift. And once your exponential function shifts up and down, what that will affect is your asymptote. Okay, so basically if you had a function and you shifted it, maybe 1 unit down, then instead of your graph passing there at 1, it's going to go 1 unit down. So it's going to pass through the origin and it's going to do something like that. Okay, and you have your new asymptote where now y is equal to -1. That's basically what a vertical shift does. And if it goes up, well, instead of it crossing 1, it will cross 2. Okay, and then you have a horizontal shift as well as a vertical shift in one scenario, okay? And if you wanted to know, does it shift left or right? Well, you just say x minus p is equal to 0, and then x is equal to p. So it shifted p units, p units to the right. If it was x plus p, it would be p units to the left, okay? So same story again. Let's say it shifted 1 unit down and it went somewhere to the right. Okay, so it won't exactly intersect at 1 anymore. Or rather, if you shifted it down, it won't necessarily intersect at 0. Maybe it might intersect a bit early and do something like that. Okay, so those are the effects that actually occur on an exponential function. All right, so one thing that is important about the value of b, okay, so we have b over here. The thing about b is it can never be smaller than 0. You can't have b being a negative value, okay? Hence, we've only had scenarios where it's in between 0 and 1, or it's either bigger than 1. So you can't have a scenario where b is smaller than 0, and also you can't have a scenario where b is equal to 0. So basically, this cannot exist. Okay? Please just be careful of that, because if it is smaller than 0 or equal to 0, then your function is undefined. Okay? Because if you have 0 to the power x, what does that mean? Honestly, what does that mean? It means absolutely nothing. So in this scenario, your function is undefined. For b being negative and b being equal to 0. Okay, function is undefined. So just like with all the other graphs, when it comes to the exponential function, you're going to have to describe what the asymptote is. And with your asymptote, guys, you're really going to look at y is equal to 0 or 1 or -1 or whatever vertical shift that we have had, right? So that would be your asymptote. There is no vertical asymptote. You're only going to get the horizontal one, okay? And then we're going to also look at the intercepts. Where does it intersect the y-axis? Where does it intersect or intercept the x-axis? You're going to have to calculate that. And with your y-intercept, x is 0. With your x-intercept, y is equal to 0. Okay? And you're also going to have to look at your domain and range. All right? So we've spoken about the asymptote. Okay? We've spoken about the x and the y-intercept. And then your domain and your range. Generally, with your exponential function, your domain, just like with a parabolic function, would be x as an element of real numbers. So you can go from -infinity to positive infinity. Okay, look at like the ones that we've sketched. You can see it can really go from -infinity to positive infinity for your domain. Okay, whether a is bigger than 1 or smaller than 1, b is bigger than 1 or in between 0 and 1, that is just your domain generally, unless if they restrict the domain, then that's something different. But when it comes to the range, that is different. Same with the parabolic function. It depends on your asymptote. Okay, so in this case, when you do specify your range, like for example, if maybe this value here, it was what, -2. Okay, you would know that your asymptote would be y is equal to -2, right? So you know your y values have to be above -2. So you can't, okay, if you were to put the range, y would be an element of -2. You can't have a square bracket there because you have an asymptote at -2. Okay, it can't be included. And it goes from -2 all the way to positive infinity. Okay, so it depends. If you have, what is it, an exponential function like this one, where your asymptote is y is equal to 0, you know your range will go from -infinity to 0, but you always have round brackets and not square brackets when it comes to the range, okay, and also the domain. So that's pretty much that to the exponential function. So what we're going to do, we're going to sketch the graph, okay, and as we do this, I actually want to start with the intercepts. Then we're going to go to the asymptote and then the domain and the range. Either sketch it first or do the domain and the range. Okay, so I need to cough a little. All right. So with the x-intercept, that's basically where y is equal to 0. Okay? So we have 0 there and 5, 3. So yeah, hey, basically what's going on in this graph. I can see there's a horizontal shift, which is 1 unit to the left because it's a plus. And we have also a vertical shift, which is 1 unit down. Okay, but anyway, let's see if we can solve this. This is where now algebra comes into play. Have I forgotten how to do it? All right, so I'm going to take 1 to the other side. Okay, and then I have x plus 1, and I'm going to divide by 5. Okay, so I have a fifth there is equal to 3. Okay, x plus 1. All right, and then I need to actually solve for x. Okay, you are in matric now. If you had this problem back in grade 11, this would be a big problem because like, what are you going to do? How are you going to solve it? But because you're in matric, and even though the lesson is coming up where you're doing logarithmic functions, yeah, we're going to basically have to use logs to solve this one. Okay, I don't see any other way of doing it. If we had the same base, then yeah, sure, we could just make the exponents equal, but we don't have the same base. So in this case, I'm going to be forced to use logs, okay? So I'm going to do it the long way, all right? So if I'm going to use logs, basically, I'll have log 1 over 5 is equal to log 3x plus 1. Okay, and I know that if I have a power there, I can actually bring it down, okay? So log 1 over 5 is equal to x plus 1. I brought down the exponent and I have log 3, okay? Yeah, so I'm multiplying this. And then I can take all the constants to one side. Okay, so basically I have x plus 1, then I have log 1 over 5 over log 3. And this is now where you have to use the calculator. I don't know how else to solve it without the calculator. So I did this the long way. When you look at the video with my husband, he'll probably show you how to do a short way. I don't know, this is just me taking a long dry instead of just, simplifying things. But I do take the long way because sometimes people forget, if I do it the other way, where does what go again? So here you don't have to think too much about it, but it depends really what rocks your boat. Okay, so it is that, and I'm gonna subtract 1. Okay, so minus 1, and my answer would be -2, 4, 6. So yeah, we definitely needed a calculator here. So basically the x-intercept is negative 2 comma 4 6 and 0. Now let us go to the y-intercept. Hopefully that will be a little better. Okay, I'm just going to do it on the side. Alright, so y-intercept, that's basically where x is equal to 0. So I have y is equal to 5 times 3, and I have 0 plus 1. Okay, this one is actually much nicer. Huh? Oh yeah, so I have 5 times 3 minus 1. Oh, this is just amazing. So 5 times 3 is 15. 15 minus 1 is 14. So yeah, this is way better than the x. Okay, so we're going to have 0 and 14. So those are the x and y intercepts. Now, let us look at the asymptote. Well, yeah, so the asymptote is quite simple. This graph has been shifted 1 unit down, all right? So because it's shifted 1 unit down, my asymptote will be y is equal to negative 1. Okay, and I think we are ready to sketch, and then we'll talk about the domain and the range. Okay, so let's see. We have 14. So I'm just going to draw a very long line over here. And have it something like that. Oh, let's see. We had a positive A. We have a positive A. Okay, so that's good. And B is also bigger than 1. Okay, so A is bigger than 1. B is bigger than 1. Okay, so that's great. We know what shape we are expecting. If A is bigger than 1, we have something like that. If B is bigger than 1, it's still like that. If B was in between 0 and 1, it would do something like that. Okay, but yeah, so what are the x and y? Oh, let me put my asymptote. So this is my asymptote over here. Okay, so that is y is equal to negative 1. And then let's plot the x and y intercepts. So the x-intercept is, I'm just going to say 1, 2, 3, 4. So 2, almost like 2,5. So this is my x-intercept over here. And my y-intercept was what? 14. So, yeah, something like that. So I have 0 and 14. I have negative 2, 4, 6, and 0. And we can then plot the graph. Okay, we know the shape that we want. Okay, so this is not in proportion. I can see I'm going to have a very tough time sketching this. Okay, I think let me make things easier for myself. All right, let me rather do this. So my graph is going to do something like that. Okay, not really, but yeah. Negative 2, 4, 6, and 0. So that's basically how my exponential function is going to look like. Now let's just talk about the domain. I did say that the domain, just like the parabolic function, it is an element of R, okay, element of real numbers. So domain is an element of R, and then my range. Okay, the range is really restricted by the asymptote. So y is an element of, we're starting at negative 1 and we're going all the way to positive infinity. And that's pretty much how you do this. We're basically done with the functions. Yeah, you'll get an exam question another time. But for now, we've covered the theory. We've did some examples. I hope you really get and I hope you understand. Please don't forget to share this quality information with your friends who are in matric or who are upgrading. But for me, it is good night.